Hello, we'll be presenting our phase 2 project presentation for our improvement on fast VIT that we trained locally on CFAR 10. In this work, we started from a baseline fast VIT pipeline and then we introduced two key improvements. First one was clip-based knowledge distillation and a hierarchical attention architecture. And our main goal was to achieve measurable accuracy improvements, analyze trade-offs, and ensure reproducibility. The base model is VIT-T8, designed for efficient vision inference with a strong speed accuracy balance. We followed a strict data protocol with 50,000 training images and 7,000 validation images, 3,000 final test samples. The training setup includes mixed precision training, ADAM-W optimizer, and a cosine learning rate scheduler. We also report the parameter count, flops, latency, top one accuracy that were required by the TAs to present.
Building on this baseline, we explored two improvement directions: an algorithmic improvement using clip-based knowledge distillation and an architectural improvement using hierarchical attention. Our first contribution is clip-guided distillation. We used clip VIT B32, 32 billion kilometers as a frozen teacher model and generated soft tables using prompt ensemble for CFAR10 classes. To keep training efficient, we cache these soft labels and reuse them using training. The student model is trained using a combined loss consisting of cross entropy with hard levels, K divergence with teacher soft levels, along with temperature scaling and mix-up. This improvement generalization without increasing model size or flops.
So our second contribution is architectural, where we basically introduced hierarchical attention, as you can see here, which is same during both training and inference. So the hierarchical attention design is with local attention within windows and global context exchange across windows. So you can see over here, we've drawn the architecture. We also removed one intermediate downsampling stage to preserve spatial details. We've removed the patch embedding that was over here. This helps us maintain richer feature representation deeper in the network. The result is a model with fewer parameters but better performance, showing improved efficiency. As you can see here, our parameters almost halved, 52% reduced, and our improvement increased.
Now coming to the results, the baseline fast PIT achieves a test accuracy of 83.5% with 3.265 million parameters. With clip-based knowledge distillation, the test accuracy improves to 85.03% with same parameters and flops. The hierarchical model achieves a test accuracy of 85.3% while reducing parameter count to 1.563 million, which is about 52% reduction. However, it has slightly higher flops and latency. The key insight is that clip distillation improves accuracy without additional cost, while the hierarchical model improves both accuracy and parameter efficiency with a trade-off in compute.
So now we'll move on to compute, the demonstration part. So our initial implementation is over here. We've implemented and received our base accuracy, our top one accuracy as 83.5%. And here are all the precision, recall, and F1 scores. And this is the overall loss versus epoch and accuracy versus epoch graph that was made, and the confusion matrix. Moving on to our CFA clip implementation. So here we've implemented a clip. As you can see, we've used prompt ensembles for the classes, and then we've trained over here and received. Uh, we've also implemented checkpointing, so that is why over here it says 1 on it. That was our 292nd epoch, so that is why it says this. And our validation accuracy was 83.93%, test was 85.03, and parameter count was 3.265 million. And here is the accuracy and loss epoch graph and the confusion matrix. I'll even start this code just for the sake of it. We won't be doing training because training will obviously take a lot of time. I have the last checkpoint.pth over here that will help us move through without doing entire training over again. We won't be doing entire training because obviously it will take a lot of time. I'll just do uh, from the last checkpoint. We have the last checkpoint saved as we did checkpointing in this code. As you can see, it says it resumed from epoch 300. I'll not execute the training part obviously, and here's the evaluation code. So as you can see, our top one accuracy is 85.03%, while our validation best accuracy was 83.81%, and here are the rest of the parameters that we were set to present. And now we'll move on to the hierarchical attention one. This is the implementation. Yeah, this is the implementation. So we made the custom model for our fast VIT hire, where we introduced hierarchical attention. We've added this file in our GitHub as well. And yeah, so in this, as you can see, so our top one accuracy was 85.3%, and our best eval split accuracy was 85.23%. And here is the loss versus epoch and accuracy versus epoch graph. And the model summary conclude telling about the number of parameters and the latency and flops. I'll execute this code as well, except the training part, obviously. Yeah, so we've started the training. I'll execute all the cells that are needed. I won't be executing this cell obviously because it is the training one. It has all the 150 epochs. One more thing that we would like to point out is we trained both the fast VIT clip and base implementation with 300 epochs, while this model, our new architecture, attained the equivalent accuracy, even better test accuracy within 150 epochs. Yeah, so our top one accuracy is 85.3%. And here we can see the total number of parameters, trainable, non-trainable flop. Yeah.
So to conclude, we improved fast VIT using both an algorithmic method through clip distillation and an architectural method through hierarchical attention. Both approaches are validated with quantitative results and are fully reproducible implementation.
Here are our contributions. So Nayan did all the model evaluation, benchmarking, and comprehensive result analysis, and he made the clip knowledge distillation training pipeline and everything. And me, I am Prakhar, and Aditya, along with me, we implemented fast VIT baseline framework and the new architecture that was involving the hierarchical attention layout. Thank you.